we have here linear graphs. Linear graphs. So linear graphs, as we said, is one of the big topics of functions, relations, and graphs. And understanding this gives you a good step to be able to do a couple different topics. So we want to identify the type of graphs that can form from a function, because remember this is connected to relations, functions, and graphs. And we want to be able to determine the y-intercept of the graph of linear functions using a formula, and then determine the gradient of a straight line using a formula. All right, so take these down. And when we talk about the y-intercept of a graph using a formula, in this instance, we are not talking about calculating the formula, but observing it from the formula. And then we're going to see how we can identify it from a graph, but we're going to be calculating the gradient from the graph. So once we do those two and put it together, we'll have the equation of a linear graph. And that would be our first stepping stone into this particular topic. All right, so the types of graphs, right? So functions, when they come together, they can be represented graphically and form two types of graphs. All right, there are many ways to represent functions. One of the ways would be a graphical representation. So you have arrow diagrams, algebraically, graphically, and as a set of ordered pairs. Now the set of ordered pairs come together to be plotted on a graph, which eventually form the graph that we know it as and what you would see. And there are typically two types of graphs, a linear graph and a non-linear graph. So clearly today our focus is going to be linear graphs, but I'll show you guys basically like examples of what those non-linear graphs can look like. So the question is, how do linear graphs look? So linear graphs look like a straight line basically. All right, so when we talk about linear graphs, that's what we're talking about, a straight line. Now, we have a representation of the different kinds that we could have. So in this case here, we have the positive gradient. Now, when we are reading from left to right, we usually read from left to right in our language. So when you're reading left to right, it goes up, right? You guys can see how this one is going up. So that basically represents a positive gradient. Once you see a gradient going up, or the line going up for the linear graph, that means it has a positive gradient. So in other words, the gradient means that the equation is continuously increasing. It's continuously increasing. And when we talk about a negative gradient, what we are saying is that as we go from left to right, you can see it falling down. All right, so it's decreasing. So that's a negative gradient. Now, as it relates to a flat line, as you can see here, that would mean that our gradient is 0. Okay, so if you have a flat gradient or a gradient that is 0, it would look like a flat line. And it is not just a flat line, but a horizontal line. So I want you guys to take these down as some examples, because it's going to be important to know when a graph has a positive gradient or a negative gradient by observation. We'll also learn to identify it if it has a positive or negative gradient based on the actual formula itself. All right, so nonlinear graphs, what do they look like? What do you guys imagine a nonlinear graph would look like?
I would think like swerve lines,
Like swerve lines. Okay, right. So nonlinear graphs, lines won't be straight. Okay, but in order to be considered a graph or function coming from a graph, it has to pass what we call a vertical line test. So if you look at these graphs here, these would be considered non-linear graph. Okay, so quadratic line graph, this is what it looks like here. This here is an exponential line graph, and these are polynomial line graphs. So as you can see, you got swerves going on here, and they are not straight like the linear lines. So quadratic graphs would be something that we look at as well too, and we'll touch on exponential a bit too. Now polynomial graphs, these are not actual graphs that we do at this level, but they do exist as well too. All right, so linear graphs, basically a set of points that can be joined by a straight line. So essentially, this is where our set of ordered pairs that come from functions come together to, show us a pattern that forms a straight line. Okay, so if you look here, we have this line and its formula is y is equal to negative 2x plus 5. Negative 2x plus 5. And this graph over here, its equation is y is equal to 2x plus 3. Now, I'm just going to show you something here quickly, and then later we're going to be discussing that. Okay? So, essentially, when you look at this line here, reading left to right, does it go up, down? What's going on?
It's going down.
It's going down. And when the gradient is going down, we would refer to it as positive or negative?
Negative.
Negative. Excellent. So this one here going left to right, this here is positive or negative?
Positive.
Positive. So I want you to explain to me, why do we consider this one on the right to be positive?
So it's aiming up, not down.
Good. So going from left to right, you see, like Justin said, when it's going left to right, it's increasing. Can you see that now?
Yeah.
Excellent. So now, based on that, what can you say about the one on the left?
Negative.
And how do you know it's negative?
So it's going down.
It's going down. All right. Now we need to talk about coordinates. All right. So I kind of quickly showed it to y'all, and I'll take it back. Now, when we are reading coordinates, we always read from the x-axis first, and then we look for the corresponding y value. All right. So for instance, this particular dot right here, this dot would be -1 because I'm starting on the x-axis first, -1, and I go straight up to 7. So -1, 7. So my coordinate there would be -1, 7. What would be this coordinate here?
1, 3.
1, 3. What would be this one over here?
0, 5.
0, 5. You're asking me or you're telling me?
7.
All right, good. One for you. What's this one here?
3, -1.
3, -1.
2, 1.
2, 1. Excellent. What about this one over here?
That would be 1, 5.
1, 5. This one here?
-3. -3.
Say that again. You had stumbled a little bit.
-3. -3.
Nice. And what about this one here?
-1, 1.
-1, 1. You sure?
Yeah.
All right, good. I had you thinking there for a little bit, man. You was on your toes there just now. All right, so yes, these are the coordinates here. As you can see, x always comes first and then y. So in this case here, this dot was -1, 7. This one here was 0, 5. This one here was 1, 3 because the x value comes first. And then the corresponding y value is 3, and so forth. Okay, so you got to be very careful when you're doing these things, identifying the coordinates. It's very important to always look for the x value first and then find the corresponding y value. So, features of a linear graph. There are 3 key features of a linear graph. So we have the y-intercept, x-intercept, and gradient. The most popular ones that we tend to focus on and examine would be the gradient and the y-intercept. Now the gradient basically tells us how we are increasing or how we are decreasing. So if we are increasing, what kind of gradient do you expect to have? A positive or a negative one?
Positive.
Positive.
Excellent. Positive. And if it's decreasing, what do you expect to have?
Negative.
Negative.
Wonderful. So I'll let y'all take this down, and then before we move on to the next phase, what I'll do is double back to our graph before so you could kind of see how that formula works with the actual graph. Okay, so take this down and then we'll talk about that. Now this is the formula that represents this linear graph here. Now how does this formula work? So basically, if I have a value for x, so let's start off with x being, say, 2, okay? So if x is equal to 2 using this formula, what that means is I can substitute or replace this x with 2. So then I would say y is equal to -2 times +2 plus 5. Now you're asking me, where did I get the 2 from? I'm just using this 2 as a random number. I could have used any other value as a sample, but I'm just showing you with this one, and then I'll show you an example with this one just so you could see how it works. So I know what the x value is. Based on this graph, we expect that the corresponding y value on this graph when x is equal to 2, So if you look at it, when x is equal to 2, we expect y to equal to what? 1. Excellent. So with this, y is equal to negative 4 plus 5. What is negative 4 plus 5? 1. So as you can see here, when x is equal to 2, our corresponding value for y is 1. And that's how we get the quadrant, because in this case, when x is equal to 2, y is equal to 1. Now, the same applies as if we were to do this formula as well over here. So let's just say in this case, this time x is 3. So based on this, when x is 3, what do we expect y to equal to?
9.
Wonderful. So let's look at it. Formula says y is equal to 2x plus 3. So we said that x in this case that we're looking at is 3. So when y is equal to 2 times 3 plus 3, we end up with y is equal to 2 times 3 is?
6.
Then 6 plus 3, ladies and gentlemen, would be 9. So therefore, our coordinate for this would be x is equal to 3, y equal to 9, thus 3, 9. So essentially, this formula here represents the algebraic expression or the algebraic equation of the actual line graph. So we can plot values in here to help us to draw these graphs. Okay, does that make sense? And as we continue to use these numbers, we would realize that we get back these answers. So if we put 0 in here, so negative 2 times 0 is 0, because anything multiplied by 0 is 0. So then 0 plus 5 is 5. So when x is 0, we expect y to be 5. And it works for all of these. So this is how the linear graph works with the formula and its reflection on the graph. Does that make sense?
Yeah.
Good. So let's talk about the components of the equation that make up a linear graph. Okay? So we describe a linear graph using a linear equation that says y is equal to mx plus c. So I just brought back our good friend here from that previous question, where we have the equation in the form y is equal to mx plus c. Okay, so if you look at this, you can see by comparison that m represents the value next to the 2. Okay, so m represents the value next to the x here, and also here 2 represents the value next to the x, which is the gradient. So we'll see that in a bit, right? So y is considered to be the dependent variable. As you saw from what we did earlier in the previous slide, we were actually putting a value of x into a formula, and that gave us the value for y. That's why we say y is the dependent variable. So therefore, that would make x the independent variable. So the value of x that we are putting into the formula gives us an output, which is y. So the value of x basically helps us to determine what the value of y is once we put it through the formula. Now, m in particular, that represents the gradient. People also refer to it as the slope of the particular linear graph. So C now, when we talk about C, C represents the y-intercept of the linear graph. So we're going to understand what a y-intercept is later as well too. But just think of it, intercept. All right, just use that word to help you kind of try to put together what that might mean. All right, so from the formula, we can see that the m part represents the gradient and the c part represents the y-intercept. Okay, oftentimes people always also use b. Mostly Americans use b for the y-intercept, but it means the same thing. This works when y is the subject. All right, y must be the subject. So in order for this to apply, y must be the subject of the formula. When I say subject of the formula, what I'm trying to say is that y must be by itself. It must say y is equal to something, not 2y is equal to something, or y divided by 4 is equal to something. It must be y is equal to whatever. So in this case, as you can see, y is the subject of the formula. Therefore, m represents the gradient of that particular formula, and C represents the y-intercept. So let you guys take that down, and then after we're going to talk about that a bit so you guys could see from an equation now. So we were just looking at the graph itself. Now we are studying the equation. So we're looking at this. We said when y is the subject of the formula, that is when we can do this, in the sense of saying that the value next to the x is the gradient, and that the constant, or the positive or negative value, whatever value we have here that does not have a variable x attached to it, is a y-intercept. We can only do this when y is the subject of the formula. So as you can see here, m is the gradient, c is the y-intercept. So looking at this equation from our previous graph, this graph over here, okay, so this is the equation that represents this graph. Our gradient for this equation here is what? What's the gradient for our equation here?
2.
2. And notice we say 2 and not 2x. We say 2, the actual value, all right? I have it color coded so you guys could see as well for yourself. So what is the y-intercept for that particular formula? 3, and not just 3, but in this case positive 3. So let's look at the next formula. So this is a other arrangement of how it can be, but the same principle applies. So based on the next equation here, what is the y-intercept? Positive 4. Does everyone understand that? Yeah. All right, so when you look at this equation, right, y equal mx plus c, m represents the gradient. So C, what does C here represent?
Y-intercept.
Y-intercept. So now by comparison, when I look at this equation and then I look down here, the value next to the x would essentially be the gradient, right?
Yeah.
What value is next to the x here?
2.
2. So what is the gradient of this equation here?
2.
2. What is the y-intercept of this equation here?
3.
3. Does that make sense?
Yeah.
No. Remember, this only applies when y is the subject of the formula. So if I put a 4 here, right, I cannot say that 2 is a gradient, okay? In the future, we're going to learn how to do and what to do in a case like that.
Multiply by 4?
We will divide by 4 because it's being multiplied by 4.
Oh, I was talking about the inside, but not the outside. You got to divide by 4.
And the inside as well too, to keep it equal. You divide both sides by 4, and then you will be able to do it. Okay?
Yeah.
All right. But that was just to show you that it only applies when y is the subject of the formula. So in this case over here now, we are looking for the value next to the x to let us know what the gradient is. And if you look here, what's the value next to the x? We have a minus 3. So negative 3 would be our gradient. Lovely. What would be our y-intercept?
4.
Positive 4. Wonderful. Does that make sense?
Yeah.
Let's look at some examples first so y'all could identify it. And then we're going to start to talk about what is the y-intercept and what is the gradient. Okay, I just want y'all to understand that using this formula, the value next to this x represents a gradient once y is the subject of the formula. And then over here now, it's a y-intercept when it's by itself, right? So y equal mx plus c is the general equation. What does m represent?
The gradient.
Yep, the gradient. And what does c represent?
The y-intercept.
The y-intercept. Now, let's say we had an equation that said y is equal to 3x plus 5. Now, if I'm comparing, I know that this one here is m and this one here is c, right? Because y is y, x is x. So therefore, m is the same as what in this equation here?
3. Whatever number is in front of the x.
Good. So m is 3. So that means for this particular equation, the gradient is
3.
good. And the y-intercept would be
5.
5. Everybody understand that?
Yes. Yeah.
Y'all got it now, right?
Yeah.
All right, so let's try two more. So let's say now we had negative 5x and then we had minus 2. So in this case, same process, y is equal to mx plus c. The m would represent the gradient and c would represent the y-intercept. What is the gradient of this equation here? Negative 5. What does the c represent? Negative 2. So negative 2 represents c, which is the y-intercept. Everyone understands that, right?
Yes.
Good. So, what is the y-intercept? So, the y-intercept is where the linear equation crosses the y-axis. It's where the linear equation or graph crosses the y-axis. So, at this point, x is equal to 0. Okay, so let's look at this here now. So, you see this first diagram here, we see that this coordinate here is 0, negative 2. All right, 0, negative 2. So, what happens here is that the yellow line crosses the y-axis at negative 2. Y'all following me? So the y-intercept is negative 2. Now, let's look over here. What is the y-intercept for this one here? 1. So 1 is the y-intercept and the coordinate of the y-intercept is 0, 1. So the y-intercept is 1 and the coordinate of the y-intercept is 0, 1. Okay, because we go on x-axis for 0, 1 is this coordinate, but our y-intercept is actually 1. Likewise over here, it crosses at this point, negative 2, and it's 0, negative 2, which is the coordinate of the y-intercept. Now, I want to go back to our first two graphs that we looked at. Now that you guys have that knowledge of how to figure out what the y-intercept is, based on this equation here, right? So let's clear this. So based on this equation here, what does the negative 2 represent? The gradient. Excellent. So the gradient is negative 2. And what does the 5 represent? The y-intercept. Okay, so therefore, when you look at this graph, where does the line cross the graph? At 5. So y'all see the link between the two? The equation and the line?
But teacher,
Uh-huh.
the gradient, which is negative 2x, right? It only affects the y-axis
In what sense?
because I see here negative 1, 7, 0, 5, 1, 3. So it going down in twos.
Ah, now you're seeing it. So, like you said, it is affecting the y because y is the what variable? What did we say y is?
Dependent.
Y is the dependent variable. Y is a dependent variable. Now, because of that, gradient, which is negative 2, which is a negative gradient, is telling us that each time we increase x by 1, it's decreasing y by how much?
2.
By 2. So that's why you see it jump by from 7 to 5, then 5 to 3, then 3 to 1, and 1 to negative 2 because it's decreasing by 2. Okay, so each time you increase one of the x values, you realize it keeps going down by 2. Now, likewise, what do you expect to happen on this one? It will increase by how much? All of them going to be increasing by 2. Yes, for the y value. Once we go in increments of these values here. So say for instance, negative 3. If we figure out the value for this one. So negative 3, negative 2. The value for negative 2 jumped to negative 1. For the value for negative 1 jumped to 1. And then 1 jumps to 3. 3 jumps to 5. Then 5 would have jumped to 7 for this particular one here. Okay, so that would have been 7 and this would have been 9, and it keeps going. So I'll explain that in a little depth after we get to this part here, right? So y'all could better understand what this is essentially telling us. I'll put a real life example to it. Okay, so I want you to tell us, based on this formula here, what is the y-intercept?
3.
How do you know it's 3? You're asking me or you're telling me? How do you know it's 3? All right, so it's not multiplied by x, so it's a constant by itself. And if you look on the graph now, what is the y-intercept? 3. So how do you think he knew that on this graph here, the y-intercept was 3? Because there is where it crosses the y-axis. So when you look at this formula here, what is the gradient?
2.
2. Excellent. So y'all catch a concept now, right? Y'all see the link between the formula and the graph now? Yeah. Let's look at the x-intercept now. So the x-intercept is where the linear equation crosses the x-axis. So this is just another feature that we consider as well. But based on our formula, the two most important ones would be what?
The gradient and the y-intercept.
Excellent. All right. So this here is just a concept that we need to know as well. Just because we have the y-intercept, we need to know what the x-intercept would be. So the x-intercept is basically where the line crosses the x-axis. All right. At this point, y would be equal to 0. So when you look here now, once the line passes here on the y-axis, that point is the y-intercept. Where it passes the x-axis, that is the x-intercept. All right. So you can see here, for this line that we have here, what was the y-intercept? Or what is the y-intercept?
2.
2. But what is the x-intercept?
5.
5. Excellent. So that there, understanding the x-intercept is just for you to be able to see the difference between the y-intercept and the x-intercept. All right. So we put them together so you could differentiate between the two. So y-intercept is when it crosses the y-axis, and x-intercept is where it crosses the x-axis. All right.
So we involved in the coordinates.
In terms of the y value,
Yeah. So x would become 0 and y will become a different number.
right? So x will become 0 and y will become a different number for the y-intercept, and then for the x-intercept, x would be a number and then y would become 0. All right, so let y'all take this down, and then after we continue into more stuff, and then I'll give you all a life example of a linear equation, so y'all could have an example to relate to. All right, we got it now. All right, so what is the gradient? So the gradient shows how steep a straight line is. We also call it the slope. All right. So as we discussed earlier, the m in the equation y is equal to mx plus c represents this gradient. Now the thing is, we have learned how to identify it from a formula. Now we need to understand how to calculate it, how to take information from a linear graph itself, extract that information, and actually work out the gradient. All right. So basically what the gradient is, it represents the change in y. When we say change in y, we mean the difference between 2 points on the graph. So that's why we get y2 take away y1. That's a change in y. All right. So let's just say you had $2. All right. You had $2 and you later get on the next month $10. So this month you had $2, and next month you get $10. So the change in what you received was what? What was the change in what you received? $8. Exactly. So that $8 is the change. That's why we say change in y, which is y2 take away y1. All right. And x2 take away x1 is also a change in x as well. So that's what we mean when we say the change. All right. So from one point to the next point, what was the difference between the y values and the x values? And then when it, just like how we said, from month to month, we had a change in the money. Same thing when it comes to rise and run. So the change in y, change in x, y represents what rise, and x represents the run. All right. So essentially, this is the formula you need to memorize. But these here represent what it actually shows. So I want you guys to take this down so you can better understand and have that for your knowledge. All right, we got it.
Yeah.
Let's break down a real life example of y is equal to mx plus c, so y'all could understand the concept fully. All right, so I know y'all got it now, but just for y'all to be able to solidify it. So let's say we had the equation y is equal to mx plus c. So y is equal to mx plus c. We say that m represents the gradient, or how much we're increasing or decreasing by, and c is like the constant, okay, or the y-intercept. Now, let's just say we were selling something. Let's say we were selling tea time biscuits. Y'all ever eat tea time biscuits? All right. So let's just say we were selling tea time biscuits, right? C would represent the amount of money we start off with. You know, like usually when you start a business or if you want to start something, you would want to at least have some kind of change. So let's say we having a business and we going to sell tea time. We want to make sure that we start off with some kind of money so that we could give back change to the first person that comes to us, right? So let's just say we start off with $5, right? So that $5 that we start off with would represent the initial amount of money. Now M is a gradient. So what M is gonna represent how much we selling each tea time biscuit for. So let's just say we selling each tea time biscuit for, let's say, $2. All right, $2. That sound like a good price?
That's what I'm gonna sell it for, so yeah.
All right, lovely. So $2. Okay, so this represents the amount of money we expect to increase by every time we make a sale. So $5 represents the initial amount of money, and $2 is the amount of money we expect to get for each sale. So a 2 essentially represents the gradient, and 5 represents the y-intercept, right?
I would believe so.
All right, so how do we write this as a formula? We would say y is equal to m. What's m?
The gradient mx
Good, which is 2. So mx, which is 2. So 2x plus 5. Now, let's just say now we sell one tea time. We sell our first tea time. Okay? So tea time sold. After we sell our first tea time, how much money do you expect us to have? So we started off with $5. Nice. And we sell one tea time. So that means by then we would have $7. Okay? So after we sell 2 tea times, how much money you expect us to have? $9. How you know you have $9?
Cause like at the second sale with a fuss.
Good. So essentially, you start off with $5. You sell a tea time, so then you got 5 plus 2 is 7. Then you sell another tea time, and you get 9. Okay. So what would happen if we sell another tea time? So by this time we got 3 tea times we sold. How much money we should have now? $11. Y'all following me? So the selling that we are doing is every time we sell a tea time, we get $2. Okay? So I could use this to work out how much money I would have after I sell a certain number of tea time biscuits. So for instance, if I was to put this in the formula, so y is equal to 2x plus 5 when x is equal to 3, we would see y is equal to 2 times 3 plus 5. 2 times 3 is 6 plus 5 equals 11. So what this formula is telling me is I'm starting off with $5. And every time I sell a biscuit, I make how much? $2. So the gradient tells us how much our money is increasing by in this particular formula. So every time we sell a biscuit, we get what? An extra $2. Does that make sense?
Yeah.
Good. Now, what do you think this would have meant if we had, for the same principle, 2x minus 5? What do you think this minus 5 and 2 represents? The 2 would mean that we are doing what?
Getting $2.
Getting $2 for every sale. What do you think the minus 5 mean?
You $5 in debt.
You $5 in debt. Basically, yes. Correct. So essentially that's what these gradients and y-intercepts mean. So if we had like negative 3x plus 7, for instance, that would mean that what's happening in this case?
You're losing $3.
You're losing $3 every time, and you're starting off with what?
$7. You ain't gonna last long.
Yes, that's correct. Looking at this, what is the y-intercept? 3. Excellent. Lovely. The y-intercept is 3. Looking at this, what will you say is the x-intercept?
Negative 1.5.
Negative 1.5. Excellent, because the x-intercept would be here, because that's where it crosses the the x-axis.
You guys see that?
Yeah? Y'all follow that?
Yeah.
Leaders, y'all follow that?
Yeah.
Yeah.
All right, so looking at this, let's pretend that it's not telling us. What is the y-intercept?
1.
1. And based on this formula here, what is the gradient?
Half.
Excellent. So, same graph. What is the x-intercept now?
-2.
Minus 2. Y'all catching the concept now, right?
Yeah.
Now, based off of this, what is the y-intercept? 2. Anybody disagrees? Good. What is the x-intercept now? What is the x-intercept?
-2.
Lovely. All right. What's the y-intercept here now?
Negative 2.
-2. Lovely. Because that's the point where it crosses the y-axis. And in this case, if you was to roughly approximate this, what do you think the x-axis? 2.75. Good. All right. So let's talk about gradient. Now, we're going to understand now how to use that formula we spoke about earlier. So that formula was a change in y over the change in x. So the gradient, okay, essentially is equal to the change in y over the change in x, which is y2 minus y1 over x2 take away x1. So obviously, in order to use this equation, we must get values that can represent this. So I'm looking at this graph here now. Now I want to pick 2 points. Now guys, whenever you're picking 2 points, pick 2 points that are obvious. What do I mean by obvious? For instance, this point here is obvious. What is the coordinate for this point here? 4, 1. Now let's look at this point here. You see this point here? This is not so obvious. I know this is 1, but where does this go? That's a tricky part. That's what I mean when I say obvious point. All right? I can try to approximate there, but it's better to always use something that we know for sure. Okay, so we have another option here. So if you look at this here, this is representing 0, -2. So this is an option as well too. Do you see any other options that we could use? -4, -5. Because I technically know that this crosses here, right? So -4, -5, right? All right, so the thing is though, let's, where you see 5, 2, let's see, 5, it doesn't quite hit 2, you see? Yeah? Right, good. All right, so check this out now. I'm going to use these 2 points because these was my obvious ones for sure. So I'm going to write down these 2 points here now. So I have 4, 1 and 0, -2. 4, 1 and 0, -2. So what I'm going to do now is label them. We always try to label them first. Okay? Always, guys. Always try to label them first. So this here, this 4 represents x. So I'll call this x1. And this one here is y. y1. All right. So what do you think I'm going to call these ones?
X2 and Y2.
Lovely. So x2 and y2. Now this is the thing here now. Before I even try to use this formula, I just want to back check just to make sure I did it correctly. So I said here, okay, this is x, so that means x here. All right, boom. So x is 4, then we go to y, which is 1. All right, this one here, x for 0, -2, that's on the y. All right, good. Now I'm going to use the formula. Now in this case, this is why it's very important to check this out. Usually people get confused with putting the x at the top and putting the y at the bottom. That's why you have to be very, very careful when you're doing these questions, okay? And labeling them, that's why labeling is very important. Don't try to skip it. Don't be like, yeah, but that's too easy, I ain't gonna do it. No, don't skip it. Put it down still, all right? So y2, good. What does y2 represent? Minus 2 or negative 2. So minus 2 subtract y1. What is y1? 1. Lovely. And then when we go over this, we'll have x2. So what is x2? 0. So we put 0 here, and then x1. We're subtracting x1. What is x1? Lovely. So that means minus 2 minus 1 would give us negative 3. So if you check your calculator, negative 2 minus 1 gives you negative 3. All right. So in case you wasn't sure, negative 3, say negative 2 minus 1 gives us negative 3. So the next thing now, 0 take away 4. 0 take away 4 gives us negative 4. So if you come here, 0 take away 4, you see that we get negative 4. So here we have this value. Now a negative divided by a negative gives us a what? Positive. A positive divided by a positive gives us what? A positive. A negative divided by a positive gives us a negative, and a positive divided by a negative also gives us a negative. So these are important to remember. Same applies to multiplication. So in this case, because I have a negative 3 over a negative 4, it's the same thing to me as having positive 3 over 4. So my gradient in this case is 3 over 4. And as you can see here from the formula we have, you see the gradient is 3 over 4. All right, does that make sense? So I'll let y'all take down this example and we'll continue going through the sheet. So piece by piece, we are building our knowledge in understanding the two most critical components of the linear graph, and that is the gradient and the y-intercept. So we know how to identify the y-intercept off the graph, and we also know how to pick 2 points off the graph to be able to calculate the gradient. All right, so we keep going through that and continue to build our understanding of this concept as we go along. So you realize as we go along, you see it, how it connects to different scenarios and situations, and you start to feel better at doing it. All right, so it's important to understand the concept, which is what we were spending so much time on, and now we're actually seeing what we are doing. So looking at this here, we have 2-point circle to kind of give us a hint as to what we can use to calculate the gradient. Now, apart from those lines, can you tell me of other coordinates that we could use to calculate a gradient? What other coordinates can we use?
-4, -2.
-4, -2. So this one here, remember, this would go this first. -2 first, then -4.
-4, -6.
-4, -6, good. What else?
0, -2.
0, -2, good. All right, so just like we did the last time, I want you guys to pick these 2 points here. You can use mine that I selected, or you can use your own. Write down those coordinates and then calculate the gradient, okay? And then we're gonna go through it together. So the good thing about a gradient of a linear graph is no matter what 2 points we choose, we will get the same answer. We will get the same answer. And always remember, we always put the y values, y2 take away y1, at the top of the equation. Make sure when you're doing this, you be careful with what values you use in x, y. First, it's a coordinate, x, y. And do not forget to put x1, y1, x2, y2 on those coordinates before you calculate. So this coordinate here is 4, 2, and this coordinate here is 8, 6. So I'm gonna call this x1, y1, x2, y2. Now no matter how we did it, if I was to call this x1, y1, and this x2 and this y2, we'll get the same answer. All right, so let's say the gradient now. We know that the gradient is equal to y2 minus y1 over x2 minus x1. So therefore I could say that y2 is 6. So 6 take away y1, which is 2, over x2, which is 8, minus x1, which is 4. So therefore we have 6 take away 2, which is 4, over 8 minus 4, which is 4. All right, so this is my answer. Or I could also say 4 divided by 4 is 1. Now if you look at this equation here, the x is by itself, which essentially implies that there has to be a 1 here. It's a positive x, so that means here is technically y is equal to 1x, all right, minus 2. And 1x, the 1, represents the gradient, which we proved with our calculations here. And based on this graph, what is the y-intercept?
Yeah, -2, -2.
Minus 2. So if we were to write the equation, if we had to write the equation y equal mx plus c, we have the most important things. We know the gradient, which is 1, and we have the y-intercept, which is -2. So we could look at this graph and get this equation. All right, we know how to get this equation. Okay. All right, so let's try our next one now. So our gradient for this one was 1. Let's see what y'all will get for this one. So for this one, gradient should equal to -half. All right, it should equal -half. It could be in the form of -6 over -12 or whatever the case is, but it should equal -half. So I selected 2 points for you, but you can also select your own points. All right, so take a shot at it, then we'll try it together. All right, so let's go through this one, right? So the coordinates. First things first, the coordinates. So this coordinates, we always read off the x first and go to the y. So this is -4, +4. So -4, +4. Now here is -2, 8, or 8, -2. What is this one?
8 -2.
8, -2, because remember guys, we read off the x-axis first. So on the x-axis, this point represents 8, and then it corresponds to -2. So now I can say my gradient formula, which is equal to y2 minus y1 over x2 over x1. So the question is, what is x2, what is x1, what is y2 and y1? That's why we have to label. So here I would say this is x1, here is y1. Now this 8 would be x2, and I'll call this one y2. Now putting this into the formula, y2 represents -2, and I'm subtracting y1, which is +4. And then that's going to go over x2, which is 8, and it's going to be 8 subtracted by x1, which is -4. So don't forget to put the -4 here. All right, it's tempting to leave it as just 4, because a minus is already here, but we still have to put the -4. So in this case, -2 take away 4 is -6. -2 take away 4 is -6. Now the next thing it's gonna ask us is 8 take away -4. Now we know that once we have these two minuses together, it's gonna turn to like a plus, right? So it's like saying 8 take away -4 gives us +12. So then we have -6 over 12, which is the same thing as a -half. All right, so that corresponds to our gradient here on this equation, so we know that we did it correctly. And our y-intercept was what? 2. So if we had to write the equation, we would say the equation is y is equal to -half x plus 2. All right, so what we worked out was a gradient, but I'm just showing y'all what we can do with that information once we know it. And the fact that we know what the y-intercept is, we could derive the equation ourselves. All right, let's see y'all try this one. You have 2 points that I gave you, and there's the other one. So let's see how y'all handle this. So what should our coordinates say? So this coordinate here should be 8, because 8 is first on the x, and then 0 for the y. Okay, and here should be -8, because 8 is -8 is on the x, and then -4. All right, so you have your 2 coordinates. There's also this one here, 0, 2, and these are the best ones. So let's see what you get. All right, so let's go through this now. So we're gonna say x1, y1. Now the point of this exercise is to allow us to see the importance of negatives and stuff. Okay, so we know that a gradient is equal to y2 minus y1 over x2 take away x1. Now y2 is equal to, this should be y2, sorry. So y2 is equal to 0 minus y1. So 0 minus y1, which is minus 4. Don't forget that. It's tempting to forget the minus part or the negative part when you already put a minus here. Now it's x2, which is 8. Subtract. What are we subtracting?
-8.
-8. Very important. So 0 take away -4. 0 take away -4 gives us +4. And then remember, 8 take away -8. So 8 take away -8 is +16. So 4 over 16 is the same as 1 over 4. Does that make sense?
Yeah.
So with this here, y'all understand the concept of y2 take away y1 and so forth. But what you need to make sure you look at and understand is the negatives. Don't forget to drop down the negatives. Don't forget to put them there, subtract them properly. You could use a calculator to work these out. And by the way, this here was supposed to be a -2. So we know that this here is a y-intercept, which is -2. And the coordinate of the y-intercept is 0, -2. Alright, so I think y'all basically got a concept here. So in this case, the gradient would equal to 1, because we know that next to the x would be a 1. And because there's a 0, we know that the y-intercept is a 0. Passes through that point. That's why you don't see it here. Alright. What is the gradient of the linear equation below? I think y'all catch a concept of picking a point and find a gradient. So from here, I think y'all catch a concept of picking a point and find a gradient and observing the y-intercept. All right. So we're gonna look at a formula just to make sure that we got the formula down packed. So what is the gradient of the linear equation below, guys? What would be the gradient?
2x.
You sure?
Yeah.
It's 2. But remember, we just said 2. Okay, we just use the number. Yeah. All right. What is the y-intercept of the equation? Someone else tell me what's the y-intercept of the equation.
1.
Excellent. 1. Now, what do you think would be the coordinate of the y-intercept? What's usually the value of x at the y-intercept?
0.
So therefore, the coordinate at the y-intercept should be what?
0, 1.
Excellent. 0, 1. So we know that the gradient of the linear equation is this 2, because when we have y is equal to mx plus c, m represents the gradient, which is 2, and c represents the y-intercept, which is 1. And therefore, the coordinate of the y-intercept is always when x is equal to 0 that we find a y-intercept. So therefore, that would be 0. We know the y-intercept, which is 1. All right, so looking at this one, what is the gradient of the linear equation below?
5.
5.
Lovely. 5. What is the y-intercept of the equation below?
11.
Everyone agrees?
-11.
-11. Remember, y equal mx plus c. The m represents the 5, and the c is represented in this case by -11. It's not a positive, so we say -11. So what would be the coordinate of the y-intercept then?
0 minus 11.
0, -11. Good. So in this case, what is the gradient of the linear equation below? -4. What is the y-intercept?
3. Plus 1.
Yes. Good. So what is the coordinate of the y-intercept?
0, 3.
0, 3. We got it now. We got it. Okay, so with this one, what is the gradient of the linear equation below?
2.
2. Lovely. Now what is the y-intercept of the equation?
0.
0. Alright, you got it now because there's no value there at C, so we know it's 0. So what is the coordinate of the y-intercept? 0, 0. And there's a special name that we refer to 0, 0. This is referred to as the origin. You guys want to take this down, this particular part here, because whenever you see a question refers to the origin, they are referring to 0, 0. So just write that down, that 0, 0 represents the origin. All right, so we want to obtain the equation of a linear graph using a line graph. Now, looking at this, I want you to determine what is the equation in the form y is equal to mx plus c. All right, y is equal to mx plus c. In order to do this, the first thing we need to identify is the y-intercept, that's one. And then the next thing we have to calculate is the gradient. All right, so you guys want us to do this one together? All right, so based off of this, what is the y-intercept? Because remember, there are two important things that we need to find a linear equation. They are the gradient and the y-intercept. So what is the y-intercept? All right, so the y-intercept, or c, is equal to 4. What's the next thing that we need to have now? So we have c. What's next?
The gradient.
The gradient. Now with the gradient, how can we work out the gradient?
Use any two coordinates.
Any two coordinates. So let's pick two coordinates. So I want to use this one here. I'm trying to stick with numbers that would be easy for me. All right, so this one here is 2, 8. And then I could probably use this one here. This one here looks easy as well too. This is 0, 4. All right, so I'm going to call this here x1 and this here y1. So x1, y1, and then we're going to use x2 here for the 0 and then y2. So the gradient, the formula for that is y2 minus y1 over x2 minus x1. So y2 in this case is 4. So 4 take away y1, which is 8, over x2, which is 0, take away 2. This leaves me with 4 take away 8 is negative 4 over 0 take away 2, which is negative 2, and that's equal to negative 4 divided by negative 2. A negative divided by a negative is what, guys?
Positive.
A positive. So negative 4 divided by negative 2 should give me what?
2.
Exactly. Now, the reason I'm writing it as a whole number is because when I divide these two numbers, I get a whole number. If I was not going to get a whole number, I would leave my answer as a fraction. All right, later down when we learn stuff further into this topic, you will see why we have to leave it as a fraction sometimes to help us out. So I have my two key things. I have the gradient now, which is m, and I have my y-intercept, which is 4, and that represented by c. So m, my gradient, is equal to 2, and c, my y-intercept, is equal to 4. So now I can come here and write my equation. So y therefore should be equal to 2x, because 2 represents my gradient, which I calculated from picking 2 points, and my y-intercept, which I identified on the graph, which is 4. So I can say y is equal to 2x plus 4. So this here represents the equation of this line. All right. Now I could always test this out and you could see if it works. So let's say, using a random number, let's say x was equal to, let's say, negative 6. If we wanted to work that out, we would say 2 times negative 6 plus 4. Now 2 times negative 6 is negative 12. We add 4 to that, we get negative 8. So when x is equal to negative 6, y is equal to negative 8. The coordinate would be negative 6, negative 8, right? As you can see here. All right, so I just proved that the formula works. All right. No, all you had to do was give me this, but I'm just showing you as an extra little thing, just so you could see how it works. I just proved that this formula works. All right, so this is what we wanted to develop. The equation y is equal to 2x plus 4. So we identify the y-intercept, easy pickings. Then we pick 2 points, found the gradient, and then we put it together. So I'll let you guys take this down as an example as to how to answer this question, and then we'll try to do some others.
Doesn't matter which order you put y2 and y1, right?
You'll get the same answer, right? But when you say that, make sure you mean in this sense. So say for instance, we had this here as x2, y2, and this one here as x1, y1. We could also have this here as x2 and y2, and this one here as x1 and y1. We just need to make sure that the numbers or the subscripts here match. So you see how we have x2, that means he had to be y2. If we said this one was x1, we had to make this one y1. Once we follow that format, we will get the same answer. Does that make sense?
Yeah.
Great. So take this down and I'll give you all one to try. On your own. Y'all ready for the real world now. Alright, so let's go through this quickly and I'll give you all the next one to do. So we got 2 points. Alright. So we got 2 points. This one I would use this one 0, 3. And I would also use this one. I could have used this as well too, right? So let's use this one. So 2, -1. Alright, so I know that my y-intercept is 3. So c is equal to 3. It's passing here. Now my next thing is the gradient. So now I have to work out the gradient. So this is the format we want to look at. y2 minus y1 over x2 minus x1. So if I label this here, so x1, y1, and then I got here x2, y2. So y2 is -1. So -1 subtract y1, which is 3, over x2, which is 2, minus 0. So -1 take away 3 gives me -4. And then I'm going to put that over 2 take away 0, which is +2. So I can see here that 2 could go into -4. So therefore I could say negative divided by a positive is a negative. 4 divided by 2 is 2. My gradient is -2. My y-intercept is +3. So therefore, in the equation y is equal to mx plus c, I can say that y is equal to -2x plus 3. Alright, so this is how I work out this particular question. I see you guys understanding this concept good. That's good. So this is going to be your last one for the night, and I'll probably give you all these two to do for homework. Alright, but for this one here now, I want y'all to do this. This is going to be the last one for today. You get those other 2 to do, as well as a worksheet. Alright, you guys doing good. So we understand now the concept that the gradient and the y-intercept are 2 important things in order for us to determine the linear equation. Alright, so work on this one, get the equation for this one, and we are done for today. Alright, so we got that right. So then here now we have x1. I'll just do it this way this time. And then y1, and call this x2, and call this y2. So what we're going to do now, we already know that the y-intercept c is equal to 3. Now we need to calculate m, which is the gradient. So we could say y2 minus y1 over x2 minus x1. So y2 is -1, take away 3 because of this y1 and this y2. Then we're going to say x2, which is -2, minus 0. So then we'll end up with -1 take away 3, which is -4, over -2 take away 0, which is -2. Once we divide both of these numbers, we would get 2. So our gradient m is 2, and our y-intercept is 3. So we could say y is equal to mx plus c, which is 2x plus 3. 2 represents the gradient and 3 represents the y-intercept. Alright, so guys, just continue to go through this stuff and practice. As you can see, we put everything together and it made sense, right? So continue to work on this and you guys will see yourself getting better.